Hello, everybody, and a very warm welcome to this new Ateme webinar called How ATSC 3.0 is Pushing Boundaries of TV Broadcasting. My name is David Jarbole, and I'm in charge of business development for Ateme in APAC, and I'm currently based in Singapore. I will be acting today as a moderator for this session. For just an intro on ATSC 3.0, for those who don't know, it's also called Next Gen TV. It's a major version of ATSC standards for television broadcasting. Standard is designed to offer support for newer technology, including, for example, HEVC encoding or HDR or Dolby AC4 audio. It can also offer additional features for like data casting capabilities, more robust mobile television support, and can enable targeted advertising. Today, to talk about this subject, I have with me 4 panelists, and I'm very excited to have them. We will address different topics around ATSC 3.0, from the basic, what are the true benefits of ATSC 3.0, to monetization and dynamic ad insertion, as well as an explanation of the new end-to-end ecosystem, with a little surprise as well during this section. We'll discuss also the ATSC 3.0 project worldwide, either new or coming soon, and we'll also talk about the technology aspects of it, including future codec, but also the impact of the arrival of 5G broadcasts. Before we jump in the roundtable discussion, I'd like to introduce our speaker today. First of all, Mark Aitken, who is currently Senior VP of Advanced Technology at SINCLAIR, a company joined in 1999. Mark is an active ATSC participant, and he has been involved in the broadcast industry's migration to advanced services since 1987. Most recently, Mark is responsible for the formation of One Media, a technology joint venture focused on development of next generation broadcast, and is serving as president since 2016. He's also the author of many papers dealing with innovative RF product and development. He holds patents for various RF devices and next-gen systems, and he has received multiple awards in the last few years. Mark will be able to share his view today and his experience on ATSC 3.0, especially on the business impact that brings this technology. Thanks very much, Mark, for joining us today.
Thank you for having me.
Our second panelist is Sesh Simha. Sesh is VP of Advanced Technology at One Media, the SINCLAIR broadcast subsidiary. He is involved in the global development of ATSC 3.0 and of wireless mobile broadcast and multicast. He's managing the company's activities worldwide and with a special focus on India. Most recently, he's managing the design, production, and deployment of Mark 1, the first reference ATSC 3.0 smartphone. Sesh has 35 years of experience in the satellite, wireless, media vertical industry, working, for example, at Teleglobe or Intelsat in the past. Sesh will also share his view on the different topics of the day, and particularly on the deployment of ATSC 3.0 worldwide. Once again, Sesh, thank you very much for joining us today.
And thanks, David. I'm really excited.
The next panelist, we know it very well. It's Mickael Raulet, our VP of Innovation at Ateme. Mickael has joined Ateme in 2015 and is currently leading the standardization effort at Ateme, and is also managing several collaborative projects with our R&D team. He's following different activities from ATSC to DVB, but also MPEG, IF, or UHD forum. He has received his PhD degree in 2006, and Mickael today will share his view on the different detailed aspects of the ATSC 3.0, especially the technology side. Thanks, Mickael, for joining us today.
Thank you.
Last but not least, we have Preetham Uthaiah. Preetham is the EVP of Strategy and Marketing at SAANKHYA Labs. He has more than 2 decades of global experience in telecom and networking industry, and Preetham has held several key leadership roles in the past at Tech Mahindra LT Technology Services or Alcatel-Lucent. He has a strong expertise in networking technology, international business development, and go-to-market initiative. He has also been an entrepreneur and a founder of startup in the area of IoT and industrial automation. Preetham currently held an MBA in International Business Management from Thunderbird School of Global Management, University of Arizona in the USA. Today, Preetham will particularly share his view on the impact of ATSC 3.0 on the receiver side. Thanks a lot, Preetham, for joining us today with our different panelists.
Thank you. Thank you, everyone. And good afternoon, good morning to everyone.
The agenda of the day will start with a quick introduction of each of the company present today for this roundtable. Then we'll move to the discussion and different questions that we will address around ATSC 3.0, and we will finish with the Q&A. You are able to ask any question that you want using the Q&A section, and we can review them at the end of the roundtable discussion. Please also note that this webinar will be recorded and made available online on Ateme website. Before we start with the introduction, I would like to run a quick poll that I'm launching right now. 2 questions, very simple one. The first one is, are you familiar today with ATSC 3.0? Yes or no? The second question is, do you plan to implement ATSC 3.0 setup? Yes, within a year. Yes, in 1 or 2 years. Yes, but not date defined yet, or not at all at this stage.
So this is like AGT in America. It's America's Got Talent, but this is ATSC's Got Talent.
Absolutely, Mark. And we have a lot of talent today around the table, that's for sure. Okay, I'm going to close it in 10 seconds for the remaining one that didn't manage to vote. Okay, I'm ending the polling now. Excellent. So I will just share the result for everybody to see. So are you familiar with ATSC 3.0? 70% of you are. And you plan to implement ATSC 3.0. 40% are not, but the rest is planning to do it whether in 1 year or at an undefined date. Thank you very much for that. That will also help our panelists maybe to orient some response and details during this presentation. So let's start. We'll start with the first introduction. Mark, the floor is yours.
Well, thanks. Yeah, it's terrific being invited here. And looking at this poll, I would say there are those that may change their mind about deployment of ATSC in the sense of turning some of those no's to maybe we should move in that direction. You know, we've been engaged in the forefront of trying to change this industry for many years. Many people know who we are. You can see here who we represent ourselves as, but I think that you really have to think of Sinclair in the context of an organization that is focused on making the absolute most out of our primary assets. And first and foremost, for decades, we have considered spectrum our primary asset, our license to broadcast, our ability to communicate and distribute. And I think that ATSC3 is very much like the introduction by Eisenhower of the interstate transportation highway network in the United States. That's what we're building, and ATSC3 is at the core of that.
Thank you, Mark. I will move to the next one. Mickael, the floor is yours.
Yeah, so Ateme is well known for its video compression. So we are part of different alliance and also MPEG working on new technologies. So that's where we are going right now. So for instance, at MPEG, we work on the next-gen codec, VVC, EVC, also next transportation format like CMAF. And we are also part of the alliance. So in case the alliance is starting, then we are also looking at also their codecs, so AV1, and they are looking at AV2 right now. So this is the basis of several then standards. So the first one is MPEG that is widely used by others. So let's say the ATSC, DVB are using MPEG standard. 3GPP with the 5G core network is also using MPEG standard. At the moment, the alliance is not used by other external bodies, but that may be the case in the future. So we are looking into those standards as well. And recently we acquired Anevia. So we are also looking at, let's say, how to do OTT. And OTT over OTA is quite important in our next gen deployments. That's all for me.
Thank you, Mickael. And the last one, SAANKHYA Labs, Preetham.
Hi, good afternoon and good morning, everyone. Yeah, SAANKHYA Labs is a wireless communications disruptor. We have been working on several wireless communication solutions. One of our biggest mainstay is what we call as a software-defined radios, based on which we have developed several solutions, including for the broadcast. We have partnered very closely with One Media and SINCLAIR to develop several solutions for ATSC 3.0 ecosystem based on our software-defined radio chipsets. One of our main product that we are bringing to the market is the ATSC 3.0 receiver chip, and this is based on our SDR again. We are also innovating on the transmit side by bringing what we call as the broadcast radio head, which is basically ATSC 3.0 radios at a low power on the LPLT kind of an architecture to provide uniform coverage for mobile devices. We are also building receivers, including the USB dongles for ATSC 3.0. In collaboration with One Media, we are also building a phone which will have our receiver chip embedded in it. Apart from ATSC 3.0, we are also actively investing and building products on the 5G side as well, and satellite IoT. That's SAANKHYA Labs.
Perfect. Thank you very much, Preetham. Excellent. That was for the introduction. Let's go then to the roundtable discussion, and let's start with the first topic and question of the day. What are the true benefits of STSC 3.0? Mark, I will start with you. Can you briefly introduce ATSC 3.0 and their current deployment?
Yeah, well, look, there's not a singular true benefit of ATSC. I think that you have to view ATSC3 as a virtual toolbox of capabilities. It's clearly the first IP-based broadcast standard. That's one to many, one to everyone. It has been built and aligned around 3GPP standards. So if you ask the question, what's the true benefit of 5G? I think that the discussion would quickly align with, it's about the integration across all platforms and the ability to hybridize the experience for the consumer. You have HEVC as a video codec. You have higher efficiency, the highest efficiency against the Shannon limit in terms of bits per hertz that are possible. When you put those two together, this standard has a 5x increase in the video capacity over ATSC 1.0. When you add its interactive environment, it's all IP, by the way. This is an all IP-based standard. When you add the hybrid functionality with the interactive layer A344 of its runtime environment, what you have is the integration truly of over-the-air and OTT together. The combined experience for a consumer opening his TV screen or opening the app on his ATSC3 enabled cell phone is the experience of both together, woven together, tightly together from inception, not as a glom, kludge add-on, but at the heart of the standard. So the benefits are truly many, but it's about, for a broadcaster, the ability to truly optimize the experience for the end consumer and optimize the use of spectrum. I think the most ingenious piece of technology in this standard allows evolution of the standard for multi-generational across multiple bandwidths. The bootstrap, as it's referred to, is this standalone element which is capable of addressing, I think it's 14 some odd million different configuration varieties. And so when you have the bootstrap, the ability to do ATSC3 for a frame of data, and the ability to drop in between frames, define time between frames of other waveforms, of 3GPP waveforms, of DVB waveforms, of other waveforms, what you have is truly an ability to weave together multiple waveforms, and waveforms, by the way, that don't even exist today will be possible in the future. When you couple that with, as Preetham stated, a software-defined radio infrastructure, you have the ability to create special purpose waveforms on the broadcast side, receive those special purpose waveforms on the receive side in that software defined radio environment, and merge the two together, and quite frankly bypass the stranglehold of sort of the structured environment that telcos have been forced into to date. So I could talk for hours, but that's probably enough for now.
Yeah, of course. Thank you very much for this intro. And indeed, ATSC 3.0 was a reinvention, right, of the DTT broadcast standard, with the target to address both the existing OTA over the airspace, but also adding OTT and internet-based transmissions. Mickael, I have a question for you. Can you talk about some of the ideas and thoughts around this convergence? And on the business side also, how do they allow to address different markets?
So yes, the first one is that they took, I think one of the benefits of internet was the OTT to deliver the unicast feed. And here we are doing the one-to-many, but using, let's say, the OTT. The best way of doing that is that we use traditional dash players in the end to receive the video, like what Netflix is doing. And also the thing is that is quite important in ATSC 3.2 is that you have also the way to personalize the TV, because the TV is not only a TV, but it's also a browser, and this particular browser have a lot of capabilities in the end. So you can have some cookies, you can have some, you have a return channel in the end, so you have also the possibility to have some add-ons. So one of the use cases that we are having with ATSC 3.2 is, for instance, that we can send the base layer through the broadcast and an enhancement layer of the quality of the video through the broadband, and synchronize everything in the end. You can also have some exotic languages. So for instance, you broadcast English and Spanish, but you have another language that you want to deliver to the end user, and by the broadband channel, you can deliver it to the end user. So that's something that we were doing with Fraunhofer and MPEG-H, for instance, during the NAB last year. So that's a target that you can do with ATSC 3.2.
Okay, yeah, please go ahead if you want to add on something.
No, that's all. I think we have many topics to cover.
If I could just add something, I mean, let's, for the purpose of this audience, ATSC3 is being globalized. As a result of the rollout that's taking place in the United States, and it's starting to become extremely aggressive in the nature of the rollout. We've got another 5 markets over the next month that will be rolled out. By year's end, we'll have a total of 25 some odd markets rolled out. And by the end of next year, over 70% of the US population will be covered. But I bring that up because, you know, there are opportunities throughout Asia, throughout, you know, the Pacific region. We've had requests from from South Africa and other nations that are looking to roll out new opportunities for DTT, digital terrestrial television, and tremendous efforts, focused efforts underway in India and that region. So the true benefit of ATSC3 is that it is now in ITU. It is available. The book reflects ATSC3 as an opportunity for DTT, and so for nations that are looking to move to the second phase of digital or are in the process of transforming from analog to digital, ATSC3 is recognized globally as the standard.
Thanks very much for that, Mark, indeed. And I like to focus also on something. ATSC 3.0 is much more user-centric than the traditional broadcast model, like TVBT or even ATSC 1.0. Good example for that are, for example, the service guide or targeted advertisement as well, or hybrid use cases. Maybe Mark or Sesh, one of the two, can you talk a bit more about this personalization that ATSC 3.0 can provide?
So let me bring it from a public safety perspective, and then I'll ask Mark to bring it from a commercial perspective. From a public safety perspective, the ability to geo-target alerts, and one of the benefits of that secret bootstrap that Mark talked about is the fact that we can actually toggle bits on a device to wake up that device, and that toggling can happen at signal to noise ratios that are well below the noise floor. So from a public safety perspective, we could geo-target warnings. And that level of personalization is something that we're going to talk about actually in another conference. This is a 5G conference organized by the IEEE on public safety and first responders. So I'm excited about that aspect of it, Mark, and please go ahead.
Yeah, I mean, the personalization, the ability to leverage this interactive environment. Because it's all IP based, and because we're using the same tools that we build our OTT environment within, for the end consumer, there's a meshing of services that really obliterates the dividing line between OTT and OTA. And it's that notion of what you want when you want it. We have a vast OTT infrastructure, a vast I don't remember the number of streaming services that we offer with STIR, for example, but STIR is 120 plus different streaming services available on demand. When you begin to add other components that we control, so to speak, like the tennis channel, the regional sports networks, you create an opportunity for embedding within the free over-the-air environment services that are specific to end users, and it becomes even more end user specific when you leverage the cell phone, if you will, as that television display and the viewer environment that can be created there. So personalization extends all the way to the likes of personalization that's done in the OTT world. You open up a service today, you identify yourself, who you are as a user, and suddenly the typical wants on your part, the ability to through alerts and informing and other overlays provide useful information to extend that positive experience for the viewer is all embraced within the ATSC3 standard.
Okay, thank you very much, Mark. Well, that brings maybe to the next question that we want to address today is about the new end-to-end ecosystem. We may have a slide just after on the typical end-to-end ecosystem. Mark, still, can you help a little bit describing what the typical end-to-end ATSC 3.0 delivery chain will be?
Well, yeah, look at this is, you have to think of first and foremost from a, waveform environment. This is OFDM. So many of the same tools that you have in other OFDM standards are available to you. Sitting in the center here is the scheduler, and that's really the end device. I could go into a much more extended diagram that shows orchestration that ties all these pieces together. But the scheduler is at the center of the standard in terms of how we portion out the spectrum and how we create the waveforms and create the multiplicity of different coding and modulation formats, from QPSK all the way up to 4096 QAM, coding rates that extend from 215 to 1315 code rates. Those things define the nature of the physical layer pipe, the PLP, an acronym that DVB folks who understand that standard will recognize. But we have the ability to apportion PLPs across the frequency. You have FDM, you have TDM, time domain, and LDM, which is layer division multiplex. So we have those tools in terms of defining how the spectrum is being allocated against specific QoS and other needs. The packager is the piece that pulls in a multiplicity of components that it's signaling, it's the ESG, it's the non-real time data. It can be a scheduled pipe, if you will, or it can be an opportunistic pipe. The NRT pipe, if you will, is where currently we're taking the broadcast app, which is this web HTML file gets pushed to the end device on a repetitive basis to create that interactive environment, and those the packager pulls in the essence, all of the essence that is going to be scheduled across the frequency allocations, and then the encoder. And as I said, HEVC, this is a sort of a viewer alert. We have deployed all of our ATSC3 based upon the Ateme encoding platform, and we have exceptional video quality in the HD domain that extends down in some cases to below a megabit. Megabit per second kind of payloads, giving the nature of scalars in today's television sets. Sesh brought up the emergency alerting, and we're launching I think November 2nd in Washington D.C. In cooperation with a Fox-owned and operated station in Washington. We're going to begin showing the industry participants the nature of the kinds of alerting and informing that can be done. And on that informing side, and by the way, part of that interactive piece, all of the content that a broadcaster has available to a station, the weather and traffic and and sports and all the content, the news that's created provides us an ability through emergency alerting to not just do the sort of the squawking emergency broadcast system kind of warning, but actually inform people the nature of what this impending emergency is, where based on geolocation, as Sesh had pointed out, the ability to track tornadoes, for example, against your specific location, hurricane. What are the emergency routes out of that emergency zone? All those things come together, and they get pushed out at the end of that. We show a couple modulators here, but in cooperation with SAANKHYA, we're doing proof of concepts around small radio heads, as we call them, which are sort of the cellularization of ATSC 3.0, where these 40-watt amplifiers with coupled with antennas on a cellular basis to do gap filling and to create an extremely robust mesh of on-channel signals. All of that gets pushed forward, and again, the receive environment is not just limited to televisions. It's there'll be a quick demo of the Mark I phone at the end of this piece, but it's also, because it's IP based, the ability in the home to extract that IP and to push that IP across home networks in the Wi-Fi environment, so that Wi-Fi enabled devices with a simple application can consume that same content that's going over the air and being brought into the home. So is that enough of an end-to-end for now?
Yes, that's great, Mark. Thank you very much. I'm sure we could spend hours, right?
Yeah, this is hours and hours. We've tried to. By the way, it's an innovators platform. We've thought of many things and many ways to use this, but we fully expect that in the process of deployments and deployments in different nations with different needs and different views of utilization, there'll be countless innovations that can be supported. Sorry, only 14 million some odd varieties allowed, but it's a good starting point.
Great, thank you. So before we do a world premiere with the Mark I demo and video, I have a question for Mickael. Well, I understand indeed that interoperability is a key element. What do you think, Mickael, are the challenges for all those equipment to be interoperable? And I will extend a little bit also. Do you think that we can reuse some existing equipment from other distribution network in this ecosystem?
So if you look at the end-to-end ecosystem, it's fairly new. So starting from the receivers, so ATSC 3.0 for receivers are becoming true from the very beginning of this year. So so we did a lot of interoperability just before. It took us quite some time to deliver audio, video, plus let's say subtitles, and then to add dynamic ad insertion, since it was also a topic of interest for the broadcaster. So all of this has been tested with various ATSC 3.0 receivers. If you go to the modulation itself, so it's a DVB-T2-like, so OFDM-like modulation. So it's based on existing modulation, an extension of that. But then the encoding, the packaging, doing OTT over OTA is really new, and that's something that they started at ATSC. That GBP was also looking into it, and 3GPP is also looking into it right now. Broadcast or multicast dash over 3GPP. So a lot of new equipment. So if you look at what we can reuse is the OTT player, that is a traditional OTT player that you can connect to a gateway. And I would say the SDI or the traditional playout that we can have from traditional way of delivering the signal to the encoder. So the playout can be also similar to what we have for ATSC 1.2. But looking at ATSC 1.2 compared to ATSC 3.2, nothing else has been reused. since the encoding is HEVC, the audio is also something else. So everything is new end-to-end for ATSC 3.0. So that means that when there is a deployment, they are not combining. A receiver is not doesn't have to be backward compatible with ATSC 1.2.
Okay. Well, talking about receiver, I guess we are very glad to show you today the world first ATSC 3.0 handset called Mark 1. So thank you very much for the people from media in SINCLAIR and SAANKHYA Labs for showing and helping us to show this video. I will launch it. It lasts just for a minute or so, and then we come back on the questions.
So, by the way, I'll say the same. The broadcast app that operates in the fixed television environment also addresses haptic control, finger control in the cell phone environment. So in the television environment, the remote control becomes your navigational aid with up, down, left, right, center, enter functionality. But in the cell phone, you end up with literally the same wipe, swipe, tap, haptic environment that people use to navigating. And this is a single chip add-on. The SL 4000 series is a integrated receiver, so it's a fully functional RF in, IP out device.
Excellent. Thank you very much again, guys. Then let's move on. Let's move on more on the technology aspects of ATSC 3.0. Well, I'd like to ask you, Mickael and Mark, would like to talk about the technology of the standard and what are some of the things added here, and in some cases, why?
I can start. So starting from the video itself. So at the same time, we were seeing some let's say some enhanced video like HDR. So the only way to deliver HDR was to use a new codec, HEVC, and that was coming at the very same time than the very beginning of the standard of the ATSC 3.2. So the idea was to convey high quality video. High quality means in general HDR with let's say higher resolution than for ATSC 1.0. So that will be that's why they were using the very latest technology that was provided by MPEG, that was HEVC at this period of time. And they were looking at delivering at the same time for mobile network and fixed network. And they saw that there was also a technology that was of interest to them, that was scalable HEVC. So the scalable HEVC is an extension of HEVC so that you can send a base layer to everybody with a more robust, using LDM with a more robust framework. And an enhancement layer that is just the difference in between the base layer and the enhancement layer. You send just the difference of the two, and you send that to mobile fixed network with a less robust modulation. So you save some bits in the end because you don't send the highest resolution with the most robust infrastructure. So that was one key topic that is quite important for them. Then they were looking at enhancing the audio. So enhancing the audio, so they took also the two latest technology that was available, so Dolby SE4 and MPEG-H. With those two, you can, for instance, have a single representation that you send to the end user for the, let's say, with various commentaries. So you have music and effect. This is how we call the bed that can be delivered in 5.1, 5.1.4. So that's the ambience that you are getting. And on top of it, you can have some objects. So the objects can be a commentary. And the commentary can be, for instance, Spanish, English, or something else, some other languages. And you can select the commentary that you want on top of the ambience. You can also enhance the audio of this particular commentary, so either increase the volume of it or decrease the volume of it, or completely remove the commentary if you want. So that's another technology that is quite important in ATSC 3.2 compared to the previous one. And then something that is quite important, it is an IP delivery system. So they use either dash route or MMT to deliver the signal, but both are using what we call ISO-based media file format. So they use IP-based delivery to the end user. And this is what we have when we use various OTT players like Netflix, like Amazon Prime. You are getting a dash player to look at the video. So they are reusing traditional OTT mechanism. And then you have what we were discussing before, is that the TV is not only a TV, but it is a browser, internet browser. So it has a lot of capabilities. It may have a return channel. Most of the time, it will have a return channel. This is what we can admit at some point, even if the mechanism can work without the return channel. But we can see that most of the TV are connected today, and they can benefit from the return channel so that they can get also some information from internet instead of only having the broadcast like traditional broadcast as of today. So I let Mark do.
Well, you know, if you continue forward from the video perspective, and by the way, this is a broadcast standard; it's not just a television standard. I'll make that clear up front. But you know, one of the primary use cases is SHVC. So the ability to propagate either in a single layer or multiple PLPs, the base layer component of a high quality video presentation, and then the addition of an enhancement layer, which does not have to be carried over the air. So you can imagine a DTT environment where cell phones you know, are capable of rendering high quality video. By the way, you know, what does that video quality really need to be, at least in terms of spatial format in a phone? We're you know, we're seeing some ideal matching of a 540p base layer with an enhancement layer to render either full 1080p HD or UHD for that matter. But that enhancement layer, which is sort of the fatter pipe requirement for that large picture viewing experience, can be delivered across multiple broadband sources. If it's a television hanging in the wall of a home, and you have broadband connectivity across cable, fiber, or other fat pipes, then you're marrying this base layer with the enhancement layer, and you know, and getting you know, high levels of efficiency in doing that. So that's just sort of the one of the TV technology that's, you know, that's being not just demonstrated, but is at the core of our launch strategy for television-based services. But as Mickael said, the IP nature of this really makes it agnostic to the kinds of data, and the interlinking of broadcast assets, meaning the interlinking in the SFN environment of a distributed on-channel resource, and the interlinking of multi-frequency networks through a broadcast core very much like the core that you would expect in the telco environment, very much like the core that that is moving forward in the cable industry. A broadcast core allows this IP data, this overlay broadcast. Look at the internet has never known broadcast. The internet has never utilized broadcast because it wasn't possible. So the ability to overlay the internet with this broadcast piece, with an underlay of unicast, working together is by far the most ingenious piece of thought process that has gone into this standard, and aligning the ability to align data frames against the 3GPP data framing structure, the ability with transport protocols like MMT to literally intermingle on a data frame by data frame basis, the indistinguishable nature, if you will, of a unicast and a broadcast together, being able to drop this content in without the the sort of the long frame sizes that are required in a dash environment, for example. All these things are, it's not one particular thing. It's all these things that have been really magnificently interwoven to interoperate across all these platforms. Again, I could go on for ages, but those are some of the first things that come to mind.
Yeah, and I'm sure you're very proud of, I mean, the Mark 1, right, handset that just arrived, right, fresh from the oven. And I have a question for Preetham, actually, about the mobile receiver evolution. How do you foresee it, Preetham? Do you think it's ready yet or not?
Yeah, I will answer the second part. Is it ready yet? I think the video that Mark showed shows where we are today. Right, in terms of the mobile receiver technology, we have already developed a receiver chip, like Mark mentioned, which is an integrated RF and baseband chip that goes into a mobile, specifically a low power chip. So we have already integrated that into a smartphone, Android smartphone, and its engineering samples are already in. Having said that, I think the evolution of receiver technology will depend on two main drivers, right? One is the market driver, and the other one is the technological aspects that needs to be considered. Market driver being, like we have been talking from the beginning of this conversation, ATSC 3.0 is not just another broadcast technology. It has features, IP-based technology, which has features that can enable multiple devices, and mobile device happens to be one of the key devices, because most of the people are consuming video and other data on the mobile device, and obviously you need to move to a mobile device. That is a key market driver. But at the same time, we need to see how the market evolves in terms of offering services around ATSC3, and that will determine the development of ecosystem, how many companies are investing in it to make it more evolved product. The second part of that is the technological part of it, right? So one of the key asks for a mobile device will be a uniform coverage and robust reception, whether you are indoor or outdoor, because any mobile user would expect it to work like any other mobile service would, right? So that will be a key factor, which means that the antenna technologies that are needed inside a mobile for receiving UHF frequency should evolve, become more compact. Mobile devices by nature have very tight space for adding new components in terms of both space as well as cost, and the evolution should also will look at how the antenna sizes will become more smaller. The chipset, how will it become more smaller or gets integrated to the existing RF receiver chips or the application processors. I think that's how the evolution will happen over the next few years. And one of the critical pieces of this evolution will be how the transmit architecture will evolve also. Like Mark was telling, we are already experimenting cellularization of broadcast transmit architecture, which would give that kind of a uniform coverage where there are gaps from the HPHT broadcast system, so that you receive these signals inside. So the combination of transmit, receive, and the mobile technology itself will determine how it will work. And we are, I think, set on the right path by bringing out the first reference design or a demo phone that Mark showed earlier.
Perfect. Yes, indeed, it's quite impressive. Thanks, Preetham, for that. I'd like to move to the next topic, which is outside of the US. We talk about South Korea and the rest of the world. ITU has ratified indeed the ATSC 3.0 standard, and now it can be deployed worldwide. I come back to you, Mark. So Korea has had this standard for 3 years now. What have we learned since then?
Oh boy, what have we learned? Well, South Korea is a very different market than the U.S. I think if you talk to the broadcasters, the three primary networks in Korea, what they would tell you is that they've learned that UHD is can be an important distinguishing feature, but it's a bit of a hog in terms of bandwidth utilization. Even the most efficient HEVC, demands effectively for if you don't want to change the nature of your business, meaning if you want to remain a television broadcaster that is dependent upon an outdoor receive antenna environment, then UHD is a service that you can offer with stunning video and stunning immersive sound, but again, for a major part of your spectrum bandwidth. A great looking TV is important for entertainment, but we're competing in a world of portable and mobile devices. We're competing against streaming services, and in the United States and other parts of the world, the increasing aggregation of these streaming services centered around big names like NBC, Universal, CBS, Disney. That programming available on a streaming nature to small devices is an area of loss for Korean broadcasters, and it was the Koreans who were most engaged in developing LDM, layer division multiplex. And the reason for that was to be able to offer a mobile tier of operation inside of that 6 megahertz of spectrum. So, Korea, Korea has I think another distinguishing factor in the case of Korea versus the rest of the world is that it was a government mandate to move to this new standard, and there'll be sort of a 1, 2, 3 move in terms of spectrum. They allocated a chunk of 700 megahertz spectrum specifically for these UHD services. Korean broadcasters can only do one service, and that service is a a single UHD service. When ATSC1 gets shut down, I believe the date is in 2027, everything will be moved back down into the core of that broadcast spectrum. And by then, I think it's the expectation of Korean broadcasters that the government will have recognized the utility of broadcast in the face of extremely, I don't want to say incapable, but one of the questions that's been asked is why ATSC3 versus 3GPP standards? Well, FE-MBMS is a broadcast multicast piece of the 3GPP standards, but it's unicast. It's unicast designed. It's not a broadcast only bearer layer, and so the ability to broadcast with a high degree of assurance that at the end of the line, the consumer can receive that content is a hallmark of this broadcast standard, and so I think you'll see over the next few years in South Korea a regulatory move to allow broadcasters to compete and provide competitive services against the telcos and move towards a mobile tier there as well.
Okay. Well, and let's try not to talk maybe about the rest of the world. And my question will be for you, Sesh. Can you tell us more about the deployments and other projects worldwide?
Oh, absolutely. And this is just extending, some of the things that Mark talked about. One major area where we have focus, not just Sinclair and One Media, not just SAANKHYA, but the entire ATSC organization partners is India. And I have a slide that talks to that. We think that there's lots of opportunities in places like Sri Lanka, Myanmar, Nepal, the Middle East, particularly the targeting the Qatar World Cup of 2022. Mark talked about South Africa. I do think that places like Kenya and Ghana would have interest and would have context and would have needs. And Southeast Asia, Indonesia, Malaysia, Thailand, and I'm hoping that there are large numbers of people in this audience from these areas. So please reach out to Ateme. Please reach out to the ATSC organization. Reach out to SAANKHYA that actually builds much of the ecosystem. If we go to the next slide, and I'd like to talk a little bit about India, and we've been spending a lot of our time there now. Now, the one reason why India is extremely important is to enable a very large mobile ecosystem. And in fact, when I joined Sinclair 4 years ago, Mark said, "Sesh, your job is to put ATSC3 on every smartphone in the world." And I said, the only place where I can start doing that is India. So that's why it's important. And ATSC has actually organized something called an India implementation team. And that team is focusing on, at this moment, preparing a technology demonstration that is going to be shown and in partnership with the Indian public broadcaster Prasar Bharati. Much of the encoding work and preparation of the signal is done in the cloud, and Ateme is, thank you, Ateme, you're a big part of this. And those signals will be delivered from exciters within the building of the public broadcaster, the headquarters, and showing a large number of use cases and to a large number of devices, which includes set-top boxes, televisions, the Mark I smartphone we looked at, smartphones with dongles, laptops with 3.0 receivers, home gateways, and so on. Now, what is important in India is number one is direct to mobile. So this smartphone will form the bedrock of this demonstration. They're very interested in the fact that you need to support large numbers of multilingual services. Education, and education even more important in today's COVID situation, where in India you have a very large number of students, primary, middle school, high school, and college, that where broadcast works very well. The ability to send large numbers of radio and audio channels, and of course emergency alerting. So this particular technology demonstration has just begun with multiple use cases, and there are 15 leading technology companies, including those on this panel, Ateme, Sinclair One Media, and SAANKHYA. So I'm very pleased and excited that many of the use cases that this audience would be interested in are things that we're actually going to demonstrate in the field in India. And if you go to the next slide, there's another effort on the part of ATSC to take that to Brazil. And in fact, Brazil has come out with something called a call for proposal for the next gen DTT. It's called the Brazil TV 3.0 project. And many requirements are aligned with ATSC3. So there are many technology companies represented that will be providing ATSC3 test projects. And one important aspect of that, which I think Preetham kind of covered, saying that if you cellularize ATSC3, then you can actually get significant improvement in spectrum reuse. And so that's an important requirement. And as over time, you will see the ATSC3 standards organization start to tackle the standardization of reuse one, where there's interference cancellation techniques that would be used at cell edges and so on. So it is very much of a living standard, and we're building upon what T2 was to our industry many years ago. I mean, T2 has had a great, DVB-T and T2 have had a great run for the last 15 years. And I think DVB has recognized that the future of terrestrial broadcasting is all about all IP, all about new techniques, all about convergence, and have kind of gracefully let ATSC take that banner and move on. So and I will give you some additional insight into what's happening with 3GPP, in a later part of this presentation. But the ATSC organization and many of the partners here are working very, very hard to take all the features of ATSC and actually showcase them in various technology demonstrations. Thanks, David.
Yeah, my pleasure. Thank you. And I guess one of the features that is driving a lot of attention is around monetization, right? And dynamical insertion. It has been advertised as a major driver for this technology. Question for you, Mark. How do you see the dynamical insertion rolling out? Do you foresee it as a driver or something that will grow as the transition occurs? And also, do you think of other type of monetization that ATSC 3.0 can bring?
Well, so in a recent study that was done by BIA, BIA is one of the reputable U.S. Firms that looks at the broadcast industry and other industries, and is done a very good job at over decades looking at trends and what those trends represent in terms of this industry. And this industry has been and will remain essentially flat in terms of its core business. They put forward a graph of the 2020 to 2030 period, and they're looking at a sustained annual growth rate of about 3 to 4% within a sustaining television environment with ATSC 3.0. So they've looked at the rollout of 3.0 and said that the sustaining nature of television will continue to grow with advanced TV and existing sources of revenue. But when you look at the disruptive side of possibilities of this DTT platform, what you see is a disruptive non-core over-the-air sustained growth over this 10 years of 8%. It comes from dynamic ad insertion, number one. It comes through higher levels of retention of over-the-air viewers. One cannot separate from the equation the fact that you have an increasing large amount of in the United States of viewers that are cutting the cable, that are moving away from those paid TV platforms, and moving towards a combination of streaming services and over-the-air services. BIA's projection is that by 2040, you'll have a very close alignment where I'm looking at one of their pages, where in 2030, 43% of the television universe, just the television universe, will be supported by cable. 40% of the viewer universe will be broadcast only. By the way, that follows from a trend that has started in 2010. In 2010, less than 10% of American viewers were dependent on broadcast over-the-air DTT. Today, that number is 20%. And so the intersection of those two drive these hybrid models of integration of over-the-air DTT functions with streaming services. Now, that clearly implies connectivity, and 70% of Americans are well connected. But on the other side of the equation, conversations are going on with some of the telco providers to integrate a 3GPP radio as a return path in set-top devices, and offering via 3.0 and via an effort underway by party not represented in this conversation, but BitPath. BitPath is putting broadcast stations together in a advanced approach to building out a national network. And so you can expect multiple stations working collectively. In the US, I would have to raise that the STC has a proceeding underway called Broadcast Internet. And many of the rules that are constraining today for television-only services are set aside for broadcast internet services. And so collectively, broadcasters can work together to offer, think of, pre-placement of content onto edge cache devices, supported by a minimal return path for interactivity request and billing reasons, and the underserved or unserved by broadband in this country will have access, due to the unique nature of broadcasting in this country, where close to 99% of the population has access to multiple broadcast stations. So monetization, when you add the OTT functionality inside of this standard, and the ability to create to either create paywalls or integrate paywalls of other streaming services into that, what nominally to a consumer looks like a broadcast environment, a device that's connected to an antenna, or as we move forward with the build out of single frequency networks and the cellularization of broadcast, you've already had, we've seen demonstrations of large manufacturers integrating an antenna into the television set, along with a home network gateway device, and you get a win-win-win, and a sustained large annual growth for the industry as a whole.
Yes, indeed, I can see that. A quick one before we move to the next one for Mickael. Technology-wise, Mickael, is there any additional equipment that are needed for doing this dynamic ad insertion?
If we look at it from OTT perspective, that's already something that exists for purely OTT. So what we use is that we use, not being too technical, but multiple period. So one period of live, one period of ad replacement, and one period of live. So this is how it will work in the end. And for that, that's already something that already exists when you do OTT. So you have
Already they are available.
That you are having for doing the ad replacement.
Okay.
The enabler for that at the moment is Kitty35, so we are coming back to the traditional way of doing this when we use a playout. So from the playout perspective, when it goes to the encoder and we do the translation from Kitty35 to the multiple period, we use a traditional way of doing that. So Kitty35, we do multiple period and then we send that to the broadcast. And you have targeted ad insertion at the receiver side.
Okay. Thank you very much. I'll try not to lose too much time. I'd like to talk a bit more about the future, if I would say, especially on the future codec and technology. ATSC 3.0 today is using HEVC as the codec, but we already have seen some new next generation of codec arriving on the market, like VVC or EVC, even AV1 and CMAF. Mickael and Mark, I would say, where next? Does ATSC 3.0 evolve also?
So I can start. So the group is already looking at future codec, at least trying to, let's say, monitor the next-gen codec. So VVC is one of them. So VVC is having a 50% improvement on top of HEVC. So it has some consideration inside the ATSC group. EVC is another codec that is essential video coding, that is MPEG-5 part 1, that is also having a good efficiency on top of HEVC, so 30% improvement on top of HEVC. At the moment, we are not really considering AV1, it's more internet or VOD like codec. So that's not considered yet for the next gen, and the improvement on top of HEVC may not be sufficient. Something that is quite important is that they are looking also at doing lower latency. So CMAF has already been considered inside the group. So CMAF is an extension of Dash where you can do HLS and Dash at the same time with the same fragmented MP4. What is quite important is in general low latency is coming with CMAF, so we can deliver smaller chunk to the next equipment that will be the multicast, and then have also a lower latency at the receiver side. So that's something that they have already started to consider, and they are already monitoring these capabilities to do that in the end. And something that is quite important, we mentioned that for Brazil, but Brazil is also looking at next-gen codec for their next, for their future deployment for TV 3.0. So that might be also a codec that may be used at some point in Brazil, because they're already looking at 8K, and probably it's also something that may be needed to go with a new generation of codec.
Okay. Thank you for that. Indeed, so the standard is evolving, right? And capabilities even for using new codec. Before we move to the Q&A section, I have one last question for you guys. 5G is definitely a hot topic nowadays, and it's coming around the corner. I'll start with you, Preetham. Do you consider it as a cooperative network or a threat today?
Yeah, I think, yeah, good question. 5G is creating a lot of buzz, and a lot of operators are deploying 5G. Having said that, broadcast as a service will be there in a 3GPP network in some form or the other. And there is a small window of opportunity. I see that we can introduce a newer broadcasting technology. ATSC3.0 has those advantages, like Mark mentioned that upfront. That it is a OFDM signaling, and it is native IP based. So, and to couple with that, 5G itself does not have a fully approved broadcasting standard yet. They're adopting the LTE broadcasting standard, EMBMS. So there is a small window of opportunity. I do not see that as a big threat if you move fast. At the same time, there is another way we can also address this issue of whether ATSC 3.0 and 5G can coexist. That is how we at SAANKHYA and One Media SINCLAIR, we are all looking at it in a converged network, right? We are building a solution that will cooperate between a 5G network and a broadcast network in a more intelligent and dynamic way, and be able to offload or direct the traffic between a broadband and a broadcast network, dynamically, right? Because at the end of the day, the broadcast brings its own advantages. That you can do a one-to-many kind of data transmission more efficiently in a broadcast network, and that is not very easily be achieved in a unicast network. For example, emergency alert system, like Sesh mentioned earlier in this presentation, and delivery of OTT content which are more viral. There are a lot of use cases where one-to-many is more advantageous, both from the delivery cost perspective, because the cost of delivering over a broadcast network is 1,000 or more times lesser than the cost of delivering a unicast message, right? So I think there is an opportunity for coexistence, but that opportunity is a limited window time where ATSC can play that role that is left void in a 5G network is something to be seen. But even otherwise, I see that 5G by itself allows non-3GPP standard networks to be connected to a 5G core, and we can leverage that to provide the cellularized broadcast architecture we spoke about, to provide the service direct to the mobile. So I think we should not look at this as a threat. There are also other technological changes that are happening in 5G, which is basically on the RAN side, which is open RAN kind of architectures that are coming into play, which gives you more flexibility to put a 5G radio technology on a cloud, right? So that you can have a radio which can have any type of RF front end and have all the baseband processing and everything happening on the DU side in the cloud. So these kind of technologies, if companies like us who can innovate and bring out solutions that will help broadcast coexist with the 5G network, or ATSC3 coexist with the 5G network, there is definitely a lot of opportunities to be had. That is my point of view.
Thank you, Preetham. Sesh, Mark, do you want to add something on that?
So actually, I've been pretty involved in this whole process, and I will tell you something very specific. Right now, 3GPP has come up with something called Release 16, and that is basically 4G LTE broadcast. We have studied this, and I have been in conversations with other terrestrial broadcasters, and the overwhelming majority feel that Release 16, although certain things have been done to make it more broadcast friendly, especially with high tower, it carries too much of LTE baggage. So I think Release 16 is going to be an interesting science experiment. So then let's move on. Release 17 is all about 5G NR, 5G New Radio, and in 5G New Radio, so far, that work on bringing the same kinds of features is still very early. So it is, if terrestrial broadcasters want to push things into 3GPP, it is going to be Release 18. That means standards won't be done till 2022 or 2023. Now, if you put the standards aside, and I think one of the problems that terrestrial broadcasters will have in ATSC in 3GPP is the fact that you're not going to be listened to much, that there's such a big momentum on the part of MNOs to dominate those standards that you won't go very far. Secondly, there's another important aspect, which is your spectrum rasters. Today, 3GPP is all about, if you take away 1.3 3 and 3 megahertz, then it's all in 5 megahertz multiples, 5, 10, 15, and 20. So all of us that have DTTB assignments that are either 6, 7, or 8 megahertz see a spectrum mismatch in anything that is in a 3GPP standard. And my understanding is that there's going to be tremendous resistance to bringing in anything that is 6, 7, or 8 megahertz. So ATSC is 6 compatible, 7 compatible, 8 compatible, and in fact, there's a possibility that ATSC will also bring in 5 and 10 megahertz into the portfolio. So you will find that there is no good solution from 3GPP yet. And broadcasters, if we get together and we decide that the future of the business that we are in is ATSC, then I think we can do all the things that people thought 3GPP can do.
Yeah. Hey, I will add to that. I mean, 5 megahertz, 10 megahertz, 15, 20. These are all already supportable within the ATSC standard, because numerically, I won't do a real deep dive, but numerically, the standard is based upon multiples of CDMA base frequency, and so numerologically, we've already proven 5 and 10 megahertz compatibility, signaled by the bootstrap. You have, as Sesh stated, you already have a conversation underway in ATSC about codifying these 3GPP compatible bandwidths. So you can get there quite easily. It's not a reinvention. It fundamentally changes nothing to the standard, other than defining via the bootstrap another operating mode.
Okay. Thank you very much, guys, for sharing your view on that. Well, that's it for the different topic. I guess we can move to the question part. I think we have already some questions have been answered. So, Mark, I've seen that you answered a lot of questions. That's great. You have done that in live. If anyone in the panel has any question, in the attendees has any question, feel free to write it on the Q&A section button, and we can reply it live. Or if you have any additional details missing, feel free to ask.
Hey, David, it would be interesting to put up a poll that says, are you now more interested in ATSC3 now that you know more about it? And as I said in an opening, I think that we've been very focused on the U.S. side of deployment, and they're very engaged in ATSC in getting the awareness, if you will, of this new broadcast standard on a global basis. And we almost singularly have been responsible for getting it into the books, so to speak, of ITU. As a matter of fact, ITU is underway right now, and several of my colleagues are virtually in Geneva as we speak, participating in ITU related activity.
So we have a question.
Anyways.
Yeah, we have a question on the chat asking, can we talk more about the public safety implications? I'm not sure if it was on the ATSC 3.0. Is there anything we want to add, Mark, on this one?
Well, no, we're working on public safety. We're working on, there are very broad-ranging concerns in the United States around issues like security of GPS. ATSC3 is fundamentally capable of supporting PNT, position, navigation, and timing, as either a secondary or primary source for those purposes. The demonstrations, that are scheduled to launch November 2nd in Washington, D.C., are centered around what ATSC calls AEA and I, advanced emergency alerting and informing. And we've actually brought tools into the newsroom so that that newsroom environment can script directly to the interactive component of the standard, and bring that into the viewing environment. There are priority levels that are followed. You have essential stuff that must be carried and displayed at all times, EAS kinds of condition content. But priority levels, a selection on the part of the user, means that there may be information that you want to see that only pertains to particular zip codes or geographic areas or areas of interest, if you will, that are generated by and sponsored by that station. A classic example is schoolroom closings. If you live in the Baltimore market, you've got a very diverse weather system here. Northern Baltimore County is a bit of a microclimate. There's a zone of 10 zip codes that during the winter are typically out of commission, while the rest of a county is in fact open. So you could imagine as a user saying, I just want the school related information specific to this zip code or this geographic area. Those kinds of things, in addition to true emergency informing, providing the rich data. There's a tremendous amount of information that is actually pushed across the PAWS system for EAS. Polygons that define areas of interest for National Weather Service related emergencies, for example. But many times the local newsroom is on the case long before the National Weather Service or other EAS kinds of warnings have been distributed, and so having those tools already available in the newsroom allows greater access, and being a mobile capable standard, putting this service into handheld devices, tablets and cell phones, becomes a sort of a critical part of that emergency infrastructure. And there is in fact legislation before states right now that is calling for the inclusion of ATSC3 in handsets delivered in those states, and that effort will increase over time. We're not looking for a mandate. We're looking for a means to provide true competition in an environment where the telcos absolutely control the nature of handheld devices today. And if we can break that stranglehold, ATSC3 becomes a massive competitive lever, as well as a major piece of filling in the advanced emergency alerting and informing needs of populations.
Okay, thanks, Mark. Another question that came in. What timelines are we looking at regarding implementation of the reverse channel in ATSC 3.0? Not sure who want to take this one.
Well, I'll say, sorry, I don't mean to hog, but in the fixed receiver environment, if you will, the TV on the wall, the reverse channel is already done. It's it's very much there. But I'll let David actually take some of the answering to this. David?
Mm-hmm. Yes.
You would like to answer this question live?
No. No, it's for you. No worries. I'll let
I'm sorry. Yeah. So look at the big screen on the wall that's tied into the internet. Reverse channel done. ATSC3 in the handheld environment of Mark phone or other phones, reverse channel already done. It's a matter of marrying multiple services together. ATSC has its own specific reverse channel, but it's unlikely that that'll be deployed in the United States. We are looking, as I said earlier, we're working, have a vibrant conversation going on with one of the telcos to use their infrastructure. Think of an MVO status, if you will, for broadcasting, where we buy in bulk a data capability. The reverse channel is typically very, very small slice. Broadcast television in the interactive environment is highly asymmetric. So I would say, actually, so the timeline is already implemented in television sets, already implemented in the first phones that we have coming into our hands, and I expect that trend to continue.
Amazing. Maybe a last question that we have about the HDR and UHD. So what are your views on HDR and UHD content over ATSC 3.0?
Do you want me to discuss? So
Go ahead.
today, SINCLAIR is deploying already in HDR using SL-HDR, so the technology from Technicolor. So the one big advantage of this technology is that you can do SDR and HDR at the same time if you want to deliver it to SDR compatible devices or HDR compatible devices. Something that we can do as well with scalable HVC is that you can do SDR 709 for instance, for mobile network, and have an enhancement layer that can be broadcasted as well in UHD, with only the difference in between the UHD and the HD. And this particular enhancement layer can have the HDR. So with the enhancement from Technicolor, you can be able to decode both the base layer plus the enhancement layer, and then apply the dynamic metadata to reconstruct the HDR. So that's something that is fairly new in this particular scheme. And they are the only one at the moment deploying these particular solutions using the backward compatibility that is SDR 709 plus UHD HDR plus 2020.
Yeah, and just for clarification, I mean, HDR is not does not have to be associated with 4K content. So, as you said, I mean, the remarkable nature of upscalers today in these, if you walk down into our lab and looked at a 75 or 85-inch television set with built-in scaling, I think that most people would be amazed at the vibrant nature of 720p with HDR, and it's and so we're talking about not just I mean, it's not HLG with sub 400 kinds of nits. When you do HDR with sort of UHD luminance values, 1,000 to 4,000 nits, those pictures just literally leap out at you. And we've launched in every market that we're a 3.0 host. We have launched at least one of our services as an HDR service. So I think there's a large dependence on the getting that content into the hands of broadcasters. We're in discussions with a couple network providers, not your typical big four networks, but I'm talking other network providers that are focused on 4K and UHD content. So when the content's available, we'll be supporting it.
Right, excellent. That's a very good one. I don't think we have any more questions right now. So, well, if you have any question, you can send it to this email address if need be, says@ateme.com. Feel free to contact us. We can pass the question to Mark, Sesh, or Preetham if need be. I'd like to thank the panelists of today. Thank you very much, Mark. Thank you very much, Sesh. Thank you very much, Preetham. And thank you very much, Mickael, for attending and sharing with us your views. This, as I said, this webinar has been recorded and will be available in our Ateme platform in the coming hours, or if not tomorrow. Thank you very much, guys, and I wish you a good day ahead on your side of the world, and a good night for the people on my side of the world. And talk to you soon.
Yeah, well, we have a little bit of sunshine coming through, so it's now not quite so early.
All right, excellent. Thank you, guys. You take care wherever you are in the world.
Okay,
Bye-bye.
thanks for the opportunity.
Pleasure.